Hello, welcome and good evening. And today is the second part of our Raspberry Pi Christmas tree series. Last time we installed Raspbian on this little Zero, plugged in the tree and wrote a little program to basically just be able to cycle through all the LEDs. What we actually want to do is get this thing into the internet and that you guys can change the LEDs on the fly and also see the results in real time on YouTube in a live stream, right? So we need not only this Pi for the Christmas tree, but we need another Raspberry Pi with a camera. So this is the Raspberry Pi camera version 2. I used it last year already. There's newer releases of this. It doesn't matter actually which Raspberry Pi camera you use, but the official ones work basically out of the box. And this here is really tiny, and I think it's a 5 or 8 megapixel sensor. And yeah, I also basically modded it a bit. Modding is too much said. This is actually fixed focus, but you can, with a little bit of force, twist this cap on the top and adjust the focus, which is needed if you want to take close-up pictures. So there's not much on here. This is the connector. You will use this flat ribbon cable inserted here and also inserted here in the camera. I think this is display here and this is camera. So we'll put it in there, and yeah, then you're basically good to go. I'm recycling an old Pi here. This is a Raspberry Pi 2. The current one is the 3 Plus, so the 2 is much weaker, but it's plenty of processing power to actually do this. The disadvantage is it has wired Ethernet, but no Bluetooth and no Wi-Fi. This is why I have a Bluetooth dongle here and also a Wi-Fi dongle here. So basically, probably don't need the Bluetooth dongle, but we'll put it in here anyway. Maybe we'll use a Bluetooth keyboard. We will install Debian or Raspbian once more. We'll use the micro SD card here for that purpose. And yeah, basically install it running Wi-Fi and also set up the camera. So first things first, the camera we can already attach. I'm not quite sure if it's important which of these things go where, but I don't think. We have to take great care. So the contacts have to be facing up from this direction. Just insert this and make sure that the clip securely holds this whole thing. Be a bit careful with that. Then we can slide this through the opening in this case. So make sure you buy a case where you can get this to the outside. And here it's similar. You have to open this bracket very carefully with your fingernails or some plastic spatula. Just lifting it up a bit. And then again, the contacts here have to be facing down. If you're looking at the back side of the PCB, and then simply pushing the black lever back very carefully, not to break off anything, and it should be holding like that. So now we can, later I will use a bit of sticky tape to tie this down and place it somewhere where it can actually record the tree. The tree itself we can just pop back together. I'll leave it assembled. And yeah, so while I'm installing Raspbian, and you already know the drill, so I won't show that for this thingy here, we will take a look at the software architecture, basically the way these things here will play together. I'll get a pen and a paper and just draw it for you, okay? Wait a second. All right, so what does the architecture look like? So basically, on this side, this is my home network, basically, right? And somewhere here is the internet. And you guys live somewhere here. You are the viewers. And also YouTube lives on this side of the big internet cloud. And what's in my home, basically? So I will have some kind of DSL router. And noteworthy is that my internal network is hidden or masqueraded behind this DSL router. So all the internet-enabled devices won't be visible from the internet, which is a good thing, because then hackers will have a hard time getting into my stuff. And we will have one little Raspberry Pi Zero with a Christmas tree. All right. We will also have the Pi camera looking at this thing with the other Pi, right? Okay, fair enough. We need some kind of script here, which I call youtube.sh, which will live stream through the DSL router and through the internet towards YouTube, basically, right? This is probably the easiest part. We will have a look at what this script actually looks like. It's basically one line, and you only need to set up YouTube. So there will be a streaming key, which is some alphanumeric code, let's say 1, 2, 3, 4, 5, 6. Well, obviously random it will be, but you will have to put that in your URL, and then you can stream to that YouTube live stream, basically, and we all can watch it. What about the Raspberry Pi Zero? There must be something going out and something going in. Going in will be requests to set some LEDs, and outgoing will be the actual status of the LEDs. Because if someone else changed them, you, the viewers, need to know what it's actually looking right now. So, and I can't just simply make a web server on this thing where I can do that, basically, right? So, in the internet, I need a little dedicated server. You can use any web server that you have access to, where you can put web pages, basically, or little programs. Dedicated server. I use the one that's hosting my website, and this will run the backend, basically. And through the DSL router, the Raspberry Pi Zero will update the status of these things, and you, the viewers, with your browsers, web browsers, can get the status of the LEDs, okay? And whenever you make a change, you can post the new status of the LED, and it will go into the backend, and my little Raspberry Pi Zero will fetch this, basically. So the update here is also some form of post to the backend. And basically the flow of information is the status gets posted to the backend, and you, as the viewer, can get the status, and the other way around, you post the new desired status to the backend, and every once in a while I will fetch the latest status that you posted there and update it on the 0. And that's basically it. The nice thing about this is I don't have to punch any holes into my DSL, firewall, or whatever here. You don't have to change anything. You just run one program here, which is a variant of the program that we coded last week. You run one YouTube shell script, which is very simple, which just streams. And you have to run one Python script here, which is basically some kind of web server, which updates the status of the LEDs in a sort of like very simple database. You can't even call it database. And then the only thing left is that we need some front end for the web browsers. Today, I will show you this part here, the script, also the client running here on the Raspberry Pi Zero, and the backend running on my dedicated server. All those programs are very simple, they have very few lines, and we'll take a look at them. And you can actually download them, they are on GitHub. And in the next part, we will show the actual front end for this. But even now, we can still use this interface to set the LEDs. So let's have a look at this whole stuff. All right, so here we are on the Raspberry Pi, and I've set it up as I did with the other Raspberry Pi. First of all, there are a couple of packages that you need to install. I already did that here because that takes literally many minutes, up to half an hour, depending on how fast your internet connection your Pi is. So the 4 packages that I installed are python-tornado, which is a Python-based web server that you can use programmatically, python-gpiozero for controlling the LEDs, because we can do it all on one Pi, although we probably don't want to do it here, and python-gpiozero was also in the last video, and also libav-tools, which gives us the capability to stream to YouTube, and Git, because I want to check out my software from GitHub. Exactly. So one other thing that you need to do is run RasPi config. I also already did that. Then go to, I think not the advanced options, rather the interfacing options, and to the camera, and say I want to enable the camera interface. This now enabled. Then you probably have to reboot. I'm not sure about that. Here I don't have to do that. And when you did that, you can run the different RasPi commands like RasPi vid. And here I can just say, please run full screen and don't do any timeout. And we can see whatever the RaspiCam sees, which is this. I can hold my fingers here and you can see how they are visible. Well, the camera is upside down, but that doesn't change the fact that it actually works. Control-C aborts this program, and that's just fine. So, how to get the software? We use Git, and Git has the command clone, and we use, let me think, https github.com/root42, obviously, /pi-xmas-tree. And this will clone the software, the latest version of the software, into a subdirectory. And what do we have here? We have basically one README file and 3 little programs. The first one is, as I said, the YouTube.sh, which you can simply run and stream to your own YouTube channel. It's rather simple. Let's take a look at it. The first few lines, the if condition is just to see if you passed any parameters, because you can pass the streaming key as a parameter to the script or enter it interactively. Passing it would be if you want to do it on startup automatically. I won't post my streaming key here because the streaming key allows you to stream to that user's stream no matter what. There's no check for any credentials or anything else. So other than that, let's open up this maybe in editor. It's probably better because I can highlight stuff. We're using the RasPi command here, and all the command line parameters you don't have to actually know. This first part here just says pipe it to another program, use auto weight balancing. Most important is probably this FPS. We are doing 30 FPS, which is good enough for this kind of purpose. And then we pipe this whole thing to a program called avconv, which basically is an encoder for video. It will read in whatever comes on standard in, and then uses a copy video codec, because RasPi will output MPEG-4 at 1 megabit. You can change this number up here to whatever you like, but 1 megabit is good enough that it works over a DSL line and looks good enough. And then here's the streaming URL from YouTube, and you have just to insert the streaming key here, which is either read from your keyboard or from the command line parameter. All the other stuff you can look up online, but actually it's of no interest here for us. What we can do now is run this thing. I will split because we need 2 more windows actually. So let's run the YouTube stuff here. Opening up YouTube, and then I have to input my streaming key, which I'm not going to tell you. And later I will make this in a startup script. So now it's already streaming, and I will switch over to Mac to show you what I'm actually doing here. Yeah, now you should see this is my streaming page. You will later have something similar. And yeah, you can see the video is coming in, even the wobble of the camera is transmitted. And basically we have YouTube streaming running. And that's pretty neat, I would say. Okay, I just aborted this so that we can actually see some stuff. The other things that we need to run are the 2 scripts we have here. The first one is the actual web server called xmasweb.py, and it looks a bit more complicated. It has quite a few lines, 90 lines, but I'll walk you very quickly through this. So basically down here we have the main program. So these few lines here at the bottom are the main program. And it just calls the make app function, which basically just returns the Tornado web application with 2 handlers, the root handler and the LED handler. The LED handler taking 1 argument, which is this regular expression. And it will listen on port 8888, and then it will start a I/O loop to listen for connections. Okay, so what do the 2 handlers do? The main handler, if you just go to that main page here, we can do that by using curl. We can run, we have to run the thing here first. Start the web server. Now it's running. We can do curl localhost 888, and it will output hello world at the start of the screen here. Yeah, do that as much as you want. Well, that's fair enough. We can also ask for the LED status. Oh, maybe not. This way. You need to add the slash here. And as you can see, you get the current status of the LEDs. They're all set to 0 initially. That is actually this handler here, and basically it stores the tree as a JSON structure with an index and a value, and then initializes itself by printing all the current values. And yeah, you can use the get method, the HTTP get method on that, and it will either have no parameter, then it will respond with all the LEDs, or if you pass a parameter, it will take only the indexed LED and put that in a response. For example, we can simply ask for only the first LED, and it would say index 1 has value 0. Well, fair enough. Also here you will see the debug output at the bottom window, so you can follow this in real time. We can also put something here and change the LED values actually. So basically we can change the curl method here. So basically what we can type here is -x put on LED2, but we also need some data to send there, and basically what we want is some value that we set, probably the correct quotation marks. And it should now be 1. When we get this exact LED, we get the value 1. And we can also set it maybe to... the rendering here is terrible. Set it to 0.5 or 0.6, I don't care. And then get it. We also see that it's got changed. So that is the put function. And the other thing that we have here is the JSON handler, basically, which serializes all the stuff and sets the default headers, because if someone else wants to, so some foreign front end wants to post here, we have to allow cross origin requests, which is basically all these headers, and also allow only those methods here and only tell the user that we accept and deliver JSON. This is all boilerplate code more or less, and not that interesting, but that's about it for this client. On the other side, the Raspberry Pi Zero with the Christmas tree itself will run the client, one of the clients, which will set the LEDs. And this is pretty simple. It is more or less the tool from the last video added with a Tornado client. So basically we have a function called getLEDStatus, which will fetch from this URL, and here it's the localhost because we already have a web server running here. And we create a new HTTP client, fetch from this URL. It's basically just like executing the curl get command that we just did, parse the JSON data, and iterate over all LEDs, get the value, get the index, and then basically set the values of the tree. And the tree again is our LED board, which you already know from the last video, and this lets us set basically the brightness of the LEDs. And this is more or less it. The only other interesting thing here is the run loop. It will periodically call the get function every 500 milliseconds, so when we run this we'll see that the web server will actually be putting out every 2 seconds here a new status response. And you can tweak this. I mean, twice per second is probably good enough for the whole thing that we're doing here. Any faster, and we might end up with probably a lot of network traffic that we don't want. So yeah, that's all there is. Feel free to check out the code. The URL I will put in the description, video description. Here's also the content still, and you can see the URL here as well, github.com/root42/pi-xmas-tree. Yeah, this about wraps it up. I hope you enjoyed this. Next time we will have a look at the front end for this whole thing and the whole setup, and we'll start the actual live stream. So share, like, and subscribe if you want to. And other than that, have a nice evening.